Hello there, greetings, salutations. My name's Tim Warner, and I'd like to welcome you to this brief lesson I've entitled, Get Started with Azure Firewall. Let's take a look at the following situation, which may or may not resemble what you've got going on in your business. Let's say you're using Azure Infrastructure as a Service, so you've deployed at least one virtual network, and on that virtual network you have virtual machines and potentially other Azure services. You know that the Network Security Group, or NSG, represents the main way to protect those VMs governing ingress and egress network traffic. However, you're not getting enough flexibility with these NSGs. You want a more robust firewall that works higher on the Open Systems Interconnection, or OSI network model. You may also find that network security groups are problematic to troubleshoot as well as generate reports on. And lastly, you realize you need a more powerful firewall solution, but you don't want to hassle with the extra configuration and cost of third-party network virtual appliances available in the Azure Marketplace. One option, available directly within Azure by Microsoft, is Azure Firewall. Azure Firewall is a managed appliance that performs OSI Layer 7 application-level stateful packet inspection. There's a low hassle factor, not the least reason for which is that you don't have to configure things like hyperscale and high availability. There's no scaling of network virtual appliance virtual machines. The Azure Firewall scales behind the scenes in a completely seamless manner. Another huge value proposition brought to us by Azure Firewall is its native integration with Azure services. Service tags, which are Microsoft IP address ranges that you can integrate into your traffic rules, the ability to tap into those, the ability to do role-based access control and Azure policy. All of your traditional Azure tools are natively baked into Azure Firewall. So for those reasons, it's a pretty compelling offering. And I'm going to give you a quick start tutorial now on how to deploy Azure Firewall and perform some basic configuration. The topology that I built for us is pretty simple. You see, I have a single virtual network that I've created 3 subnets on. My workload subnet contains a Windows Server 2019 virtual machine that has, of course, a TCP/IP configuration based on its network interface card, private IP address, non-routable, no public IPs. You'll notice that I'm using Azure Bastion, which I cover elsewhere in my YouTube channel, so please check that out, by the way, as a way to get to the VM from the management plane securely over the internet. Notably, I'm not affixing a public IP address to WinVM1. Instead, what we're going to do here is deploy Azure Firewall on its own subnet. That firewall needs to have a persistent internet connection, and then we're going to have the path being into the VM from the virtual network, and egress traffic from WinVM1 will be force tunneled through the Azure Firewall. Let me show you how it works. Now for the demonstration. I'm logged in with my subscription owner account, and we'll start by going to my lab VNet virtual network, and let me just show you how I've configured it. Looks like we've got a single address space of 10.30/16, and for my subnets, let me order these in an ascending way. I've got my workload subnet at 1032/24. My Azure Bastion's already deployed, that's on .3, and I created a subnet called Azure Firewall Subnet. So my first tip for you is set up your network prior to deploying Azure Firewall. It needs to be, that is, the appliance needs to be on its own dedicated subnet, and it needs to be called Azure Firewall Subnet. According to the docs, the network ID needs to be /27. I use Class C boundaries here as a matter of habit, so I've done a /24. Other than that, it's just a plain old garden variety non-delegated subnet. It doesn't have any NSGs on it. It's just a plain old subnet. You might have noticed that when you create a virtual network in the Azure portal, you have the ability to deploy a firewall directly from there. After creation, you'll notice that we've got the firewall setting in the context of the virtual network. Azure firewalls are also stored in a separate resource blade, as you can see right here. I'm going to do this deployment from the context of the virtual network. So we go to the firewall setting and click here to add a new firewall. Looks like my subscription and resource group have already been correctly populated, so I'm going to give this instance a name and make sure that it's in the same region as my network infrastructure. Now, it is possible to deploy a single Azure firewall in your hub virtual network and then use that across peered VNets. However, if you look in the Azure Firewall FAQ, Microsoft says that if you're going to do what's called global peering, where your spoke VNets are in different regions, you might have an unacceptable level of performance due to latency. So the doc suggests that you deploy firewalls per VNet. Now that can get very expensive, unfortunately. If you've looked at the Azure Firewall pricing, when I checked it just today, I'm recording this in February 2020, it's a little over $900 US dollars per month per firewall. So compare that with the cost of a third-party network virtual appliance. Notice that the Azure Firewall can in fact handle availability zones, and you can make it availability zone aware if you're using those. We're not going to create a new virtual network, but we're going to place this appliance on my lab VNet, and it's going to default to the Azure Firewall subnet that I created. Now, you can't do service chaining with Azure Firewall, which means you can't keep it all internally within a network. The Azure Firewall has to terminate on the internet. So we're going to have a public IP address resource, and I'm going to create one right now called Firewall pip. And that is, in my region, that's availability zone aware, going to mean that we do a standard SKU with static assignment. That's perfectly okay. If our governance policy requires taxonomic tags, we can do that. And then we go, as usual, to the validation page, where if we've passed validation, we can submit the deployment to Azure Resource Manager and follow along. Once our deployment's complete, we'll click Go to Resource to go directly to our new Azure Firewall, and let me show you around. We're not going to get into threat intelligence in this tutorial, but this is yet another selling point of Azure Firewall. What you can do here is turn the feature off, or you can just have it alert or alert and deny when Azure Firewall detects traffic either to or from known malicious IP addresses and DNS domains. Now, in this example, what we're going to do is we're going to create two rules, one of which allows for DNS traffic to particular DNS server addresses. That's going to allow our virtual machine to do DNS lookups. It's important to say this and to create this rule because if a traffic pattern doesn't match a rule that you've explicitly created in Azure Firewall, then Azure Firewall will drop that traffic by default. You see what I mean? So on the rules page, the rules blade, we see there are three types of rule collection. NAT, which is network address translation. You normally do that to allow inbound connectivity to particular VMs and resources in the virtual network. There's the network rule and the application rule. The network rules are evaluated before application rules, and let me just show you how that works. To do our DNS rule, we're going to make a network rule collection. So we'll click Add Network Rule Collection. I'll give it a name. I'll call this Workload Network Rule Collection. I'm not feeling particularly inventive with my names, am I? The priority numbers, lower integers, represent higher priorities. This is, in fact, a collection of one or more rules. That's why it's called so. The values can be between 100 and 65,000. So it's, again, similar to network security group priorities. I'm going to start with 1,000. Your actions are either allow or deny. Now, in this case, you can do rules either based on port protocol and IP address, that's what this first row is, or you can make rules based on service tags. Remember, service tags are identifiers that collect a whole bunch of Microsoft-owned IP addresses. This is going to be important for you because remember, the Azure Firewall will drop all traffic by default. So if you have resources in your VNet that needs to communicate to other Azure services, you better allow those. And because this is a multi-select, you can create a single rule that incorporates or allows traffic to all of the service tags that you need. In our case, though, we're going to create an allow DNS rule. Now, DNS, you probably know, is principally UDP, but can also be TCP, so I'll select both of those protocols. The source address is going to be the IP range of our workload subnet, isn't it? So let me open up another browser tab and let me open another instance of the Azure portal here because I just frankly forgot what that network address is. Let me quickly navigate back to our virtual network, navigate back to subnets, and our workload subnet is 1032. Note that well. So our source address here for DNS is going to be 10.30.2.0/24. Our destination address or addresses, this is a comma-separated list, and I'm going to use the Google public DNS servers for this address, 8888 and 8844. The destination port, again, you can do a comma-separated list, or you could do star to denote all. 53 is the well-known port for DNS, though, so I'll finish the rule by adding 53 as my destination port, and then click Add to complete that network rule configuration. You see the banner says that Azure Resource Manager is updating Azure Firewall with our new network rule collection. We can march ahead as the firewall is updating. Let's now go over to Application Rule Collection and click Add Application Rule Collection. We see much of the interface is the same. I'll call this Workload App Rule Collection. Again, priority values just like we had before, and the action is either allow or deny. Now, this is different from the network rule. The network rule operated on the basis of IP addresses, ports, and protocols. Here, we're working at OSI layer 7, so we're dealing with domain name system or DNS names. Specifically, we have the top level, which are FQDN tags. If we come over here, these are basically resource providers. So again, it's similar to the idea of the service tag, where you can allow traffic to particular resource providers in your subscription to make sure that you've got connectivity within your virtual network to those services. However, because we're dealing with external services in this example, we need to come down to the bottom under Target FQDNs, and I'm going to say Allow PS Gallery. I didn't actually tell you what I was hoping to accomplish here. I'm sorry about that. Let's say that we want our virtual machines to only be able to make an outbound internet connection to the PowerShell gallery. Maybe for configuration management purposes, you need to download modules and scripts from the PS gallery, so we need to create that allowance here. So once again, we specify a friendly name for the rule and a source address range, and I forgot it yet again. One of those addresses that goes right out of my brain. 1032. Okay, so let's put that in one more time. 10.30.2.0/24. For protocol and port, we can put in both or either. I'm going to do HTTP, HTTPS. And for the target FQDN, you can do wildcards here. So if I want to make sure to incorporate every host or subdomain under PowerShellGallery.com, I can do something like this, star.PowerShellGallery.com. Once I've completed that rule, I can click Add to commit it to the firewall. Are you with me so far? So far, so good? Well, we're almost finished with this configuration. At this point, we've completed the rule set on the firewall, and that's all well and good. The firewall is on the network, but we're not going to be routing any traffic to it at this point. So our final config step before we test is to come to the overview page of the firewall and make a note of the private IP address. I'm actually going to copy the device's private IP to my clipboard. We're going to define what's called a user-defined router, UDR, in Azure, and we're going to associate that route table with the workload subnet in our virtual network, and this is going to define a default route or a next hop address such that any VMs on that subnet, all egress traffic will have to go through the Azure Firewall. So, to accomplish user-defined route, we can do a search for route tables, and in the route tables blade, we can click Add. I'm going to call this workload route table, specify my correct resource group and location, and then click Create. The route table is a container. It really doesn't do anything. It's completely inert unless and until you A, define at least one route entry in the route table, and B, you associate the route table with a subnet. Let me refresh the view. Next, we'll navigate into the route table, browse down under Settings, Routes, and click Add to define a new route. I'll call this workload default route. The address prefix here. Now, we want this to be a default route that applies to every bit of egress traffic for that workload subnet. So to define a default route, you do 0.0.0.0/0. So in other words, this route is going to be applicable for every single bit of egress traffic. For next hop type, we're going to choose virtual appliance from the list and then paste in the private IP address of our Azure Firewall's network interface. Let me click OK. Now, you might have seen that warning that the portal told us that you also have to make sure that you configure IP forwarding on your network virtual appliance. We don't have to do that because we're using Azure Firewall, and Microsoft has already taken care of that detail for us, which is pretty cool, I think. There's our route. Now, we're still not finished with this route table. We have to come under Settings, Subnets, and now associate this route table with the appropriate subnet. We'll click Associate from the toolbar. We'll select our lab VNet from the virtual network list. And lastly, I'll select Workload as the target subnet. Excellent. If you're wondering what the network actually looks like, I can show you that. We can go back over to the virtual network and search the settings list for Diagram. Diagram relies upon the Network Watcher tool to give us a really nice vector topology diagram. So here's our lab VNet. We've got our Azure Firewall subnet, and we know that we have a firewall there. I have Azure Bastion, and I have in fact deployed a Bastion host, even though the diagram doesn't show it. And then on our workload subnet, we can see my Win VM1 virtual machine, and we've got the workload route table and the workload default route also associated with that subnet. I think we're ready to test now, so let's click Win VM1. First of all, verify that the virtual machine is running. It is. So we can go to Connect. And because we're using Azure Bastion, I'm going to select Bastion on the Connect to Virtual Machine blade, and I'm going to authenticate with a local administrator account. Put in my password and click Connect. It's going to open in a separate browser tab, as you can see here. Let me open up Internet Explorer, and let me go out to https://PowerShellGallery.com. There it is. Showed up almost instantaneously. Now, what if we did the similar URL and did a search to PowerShell.org, if you've ever heard of that site? We can't get there. Or what if we attempted to go to Google? No, we see a familiar HTTP request to this address, action deny, no rule matched. It's just not going to work because of our Azure Firewall rules. Excellent. Final bit of test here. Let me open up an elevated PowerShell prompt and let's enter NSLOOKUP. I want to demonstrate that we're using only the authorized DNS servers. Actually, I just thought of this. I don't think we've configured that yet. So let me come back here. Let's come back to our Azure Bastion and close that session. What I'm saying here is that in order to test that our DNS addresses that we're allowing in Azure Firewall are the only DNS servers that the VM has access to, we'll want to make an optional change here. So let me quickly jump back one more time to the virtual network and come down under DNS servers. Remember that by default, your VMs will receive Azure provided DNS. And Azure provided DNS uses the virtual IP address 168.63.129.16, but we can override that here. And because our Azure Firewall is allowing the Google servers, we might as well automate that by giving the VM those two server addresses. And as a fail-safe, I don't think I have to necessarily add that virtual IP of Azure in, but I'm going to just to be safe. When you change the DNS servers in the virtual network, as the warning says, Azure will reboot those virtual machines. So we'll have to wait a moment to get our Win virtual machine back up. Let me select it from the list here, and I'll pause the video while we're waiting. Okay, the virtual machine is back from the restart, so let's connect once again. Go over to Bastion, authenticate as usual. Okay, so as I was saying, we want to open up a elevated console session. We'll do that with PowerShell. And we can enter NSLOOKUP interactive mode just to do a search, for instance, on a domain name. So we're resolving fine. We're connected to 8888, which not only we're allowing on Azure Firewall, but I made sure is distributed to this VM via Azure DHCP. Now, if we change the server to maybe Quad9, another public DNS provider, and now we attempt the same thing, PowerShell.org, we should see this timeout. Yep, it sure does, because we have that network rule collection. Let me Control-C to stop that. That allows DNS resolution traffic only to occur for Google DNS. So there you have it. Learning resources that I've hand-selected for you. Here's a short link to the Azure Firewall docs homepage, timw.info/NF1. There's a couple useful articles in there. One is the docs article on Azure Firewall rule processing logic. That is timw.info/NF2. And then if you want more information on destination NAT filtering, which we did not get into in this tutorial, check out timw.info/NF3. I want to thank you for taking the time to watch this video. I appreciate you very much, and I look forward to interacting with you. You can find me on Twitter at TechTrainerTim. My Pluralsight library is at timw.info/PS, and my website is techtrainertim.com. Take good care.